Today's Maths for Real is all about correlation. It's about establishing whether or not there's a relationship between two sets of data.
There you go.
Oh, lovely, thanks.
For instance, is there a relationship between the number of ice creams sold per day and the outside temperature?
Or is there a relationship between the number of Maths for Real programmes you watch and the grade you get at maths?
To find out if a correlation exists, you first need to collect some data and then plot it on a diagram called a scatter graph.
Yes, we present the Maths for Real guide to the different types of correlation you'll meet and their scatter graphs. So, scatterbrains, stay tuned. Over 20,000 cabs work the streets of London.
But there's more to being a taxi driver than meets the eye. Each cabbie has to learn what's known in the trade as the knowledge.
Yeah, they're tested on their detailed knowledge of over 25,000 streets. And I thought just passing my exams was hard work.
Does that mean taxi drivers have bigger brains than the rest of us? Do you think you've got a bigger brain than the average person?
I think I might well have. The information that I have to remember is quite a lot, so it has to go somewhere, so maybe my brain is quite expanded.
Did you feel that while you were learning it, your brain was getting sharper and your memory was getting better?
My memory definitely improved. It had to, as I'd never have got the licence in the first place.
Taxi drivers' brains have been investigated by scientists at the Wellcome Institute of Cognitive Neurology. See you later, Jamie. There's a special part of the brain involved in navigation. It stores a mental map of your surroundings, and it's called the hippocampus. In there. Scientists wondered if this part of the brain was bigger in taxi drivers who had spent longer navigating the streets of London. So they used a machine like this to scan the brains of several taxi drivers. From the scans, they were able to measure the cross-sectional area of the hippocampus. This is their original data. This column here shows number of years in the job, and this column here shows the hippocampus measurement. It's difficult to see a connection between the two columns from just looking at the data. For a proper mathematical analysis, you need to plot a scatter graph. Like any graph, a scatter graph has two axes. On this one, the horizontal axis shows the number of years as a taxi driver. And the vertical axis shows the size of the hippocampus. The pairs of values from the results table can then be plotted on this graph. The data points don't exactly lie on a straight line. They appear quite scattered, which is why, you've guessed it, it's called a scatter graph. From this, we can establish whether the amount of time spent as a taxi driver and the size of the hippocampus are related. Look at the general pattern of the points. They might seem a little bit scattered, but they're mainly in a band that goes diagonally across the graph. The general trend is that as the time spent as a taxi driver increases, the size of the hippocampus also increases. The two factors are in a direct relationship. There's a correlation, which means the longer you've been a taxi driver, the bigger your brain.
Here's some scatter graph terminology. If the values in one dataset increase and the corresponding values in the other dataset also increase, it's called a positive correlation. The closer the points are to forming a straight line, the stronger or higher the correlation. This is an example of a high positive correlation. Now, if the points are more loosely scattered around a straight line, then the relationship between the two sets of data is weaker or lower, and this is a low positive correlation.
The points on a scatter graph don't usually lie in a straight line, but you might be asked to draw something that's called the line of best fit. You don't join up all of these points, but what you do need to do is draw a straight line that comes as close as possible to all of the points you've plotted. I think it's going to have to go somewhere like this. And that is my line of best fit. The taxi data shows a fairly strong positive correlation. It's worth remembering when you're drawing a line of best fit that it doesn't always go through the origin. And when you're drawing that line, try and get an equal number of points above and below the line. Oh dear, my brain hurts after all that, and I said I'd meet Jamie, but I can't remember the way. Guess my hippocampus just isn't quite big enough. I'm going to need some help. Taxi!
Sports scientists spend a lot of time looking for correlations in the hope they'll be able to predict how well an athlete will be able to perform.
For example, hi Jamie, experts at Lily Shaw's Human Performance Centre have discovered a useful correlation that allows marathon runners to predict their running time based on a measure of their fitness.
Okay, how can you do that, sort of run and talk?
Don't know.
I've always fancied running a marathon. Can't be that hard. I mean, I've seen it on the TV a few times. I reckon I'd probably do it in about 4 hours, you know.
4 hours? I don't think so.
Why, do you reckon you can do any better?
Well, maybe.
Well, Kate, there's only one way to find out, and it starts with a tough treadmill test, eh? Think you're up for it?
Definitely. We're looking at the relationship between something called VO2 max and marathon running time. VO2 max may sound a little bit techie, but it's simply a measure of fitness. It's the maximum amount of oxygen that your body can take in and use per minute, which is why Jamie's wearing that rather fetching mask. Jamie and I have to run until we're exhausted. The mask is linked to a computer. It measures our oxygen uptake and calculates our VO2 max.
Whew, that was hard work. I think it's your turn, Katie.
Scientists have measured the VO2 max levels of experienced marathon runners and plotted the results against their marathon finishing times on a scatter graph. Jamie has got the results.
In this case, the horizontal axis shows the marathon running time in minutes, and the vertical axis shows the VO2 max measurements. This is an example of a negative correlation. As the values of one set of data increase, the corresponding values of the other set of data decrease. The greater the VO2 max, the fitter you are. Hence, the shorter the marathon running time. A scatter graph needs a line of best fit, like this one here. Remember, it's important to get it to as close to as many points and have an equal number of points either side. Now, I'm using this to predict mine and Katie's running times, and as I think I'm going to be running for a long time, I'm going to need to extend it a little bit. It's a negative correlation because the line slopes down from left to right. Because all the points are so close to the line, we can say it has a high or a strong correlation. And because the relationship's so strong, experts can use this line to predict marathon running times based on a person's VO2 max value. And talking of VO2, I wonder how Katie's getting on. So what are our predicted running times?
Well, I just checked the results.
Good.
And my VO2 max was 35.
35. Okay, so I go along to the best fit line. That's 300 minutes.
5 hours, pretty good.
Not really. What was mine?
Yours was 45.
45. 2:55. That's 15 minutes over 4 hours. Like I told you, Katie, I might not be very good at stretching, but when I'm on that track, I'm like lightning, just gone, you know.
It's that part of the programme where Jamie and I have to do some maths for real. We've both got to answer the same typical exam question.
But only one of us will give the correct answer, while the other makes a deliberate mistake, which you have to spot. So keep your eyes peeled to decide, will you tick it, or will you trash it?
This scatter graph shows students' percentage scores in maths and science exams. The question asks us to A, draw a line of best fit, and B, describe the type of correlation between the maths and science scores.
The question asks us to A, draw a line of best fit, and to B, describe the type of correlation between the maths and science scores.
First up, this is my line of best fit. I chose to position it here because it's as close to as many of the points as possible, and there's almost an even number of points on either side. And I describe the correlation between the science scores and math scores as positive.
This is my line of best fit. I chose to put it here because it's close to quite a few of the points and goes through the origin. I also describe this correlation as positive.
So, whose working should you tick and whose should you trash? Who made the deliberate mistake?
Was Katie right to draw the line of best fit in this position?
Or was Jamie right to draw the line of best fit in this position?
OK, it was me that made the deliberate mistake. For this scatter graph, I was wrong to draw the line of best fit through the origin. Don't be fooled by thinking a line on a graph should always go through 0. Sometimes it should, but not always.
The key is to try to get the line as close as possible to most of the points. The line of best fit should have looked more like this.
We were both right to say this is a positive correlation. You might be tempted to describe the correlation by saying as the math scores increase, so do the science scores. But that isn't the description the examiners are looking for. That's describing the relationship and not the correlation.
When you get a question asking you to describe a correlation, remember the key words the examiners are looking for are positive, negative, or no correlation.
Acne is a skin condition that affects almost everyone. I mean, even the odd Maths for Real presenter gets it. Katie. But what causes spots?
Bacteria in the skin.
The soap, it gets stuck in your pores and you end up with spots because it blocks them up.
A bad diet.
Fatty food, loads of sugar, loads of coffee. Dirt in the pores.
Scientists at the Skin Research Centre in Leeds thought there might be a connection between the amount of bacteria on your skin and the number of spots you get. So I've come to a car park in the middle of nowhere to meet a man in a blue van. Now, they said it's big and it's blue, and I couldn't miss it. Oh, there it is. Oh, silly of me. You must be Mark.
I am, hi.
Mark, you're meant to be a spot man. Why have you got a van?
Well, this is a mobile lab that lets us go all around the country studying skin diseases. Do you want to have a look?
That'd be good of you. Let me help you out. Now, you say you've been studying skin, but what exactly does that mean?
Well, we've been trying to see whether there's a correlation between the number of spots you have and the amount of bacteria on your skin.
So how do you count the number of spots?
Well, it's quite simple, really. We simply look at the whole face and count the number of spots that there are.
Nice task, I imagine.
Yeah.
What about the number of bacteria? I mean, that must be harder to count, surely.
Well, that's a bit more difficult with bacteria being so small. So what we have to do is grow them up. And we have a special machine here which puts the bacteria onto plates.
What exactly were you expecting to find then?
Well, we thought we might find a positive correlation between the number of spots on your skin and the amount of bacteria.
But this here is a scatter graph of your results, isn't it?
It is. As you can see, on the horizontal axis, we have the total number of spots, and on the vertical axis, the number of bacteria per square centimetre of skin.
But Mark, with all these data points spread around, it must be very hard to draw a line of best fit.
Well, that's right. As you can see, there is no correlation, so you can't actually draw a line of best fit.
But were you surprised by this result then?
Well, not really, because acne is not just caused by bacteria. There's a number of different factors that contribute to the disease, such as hormones and stress.
Oh, does that mean I don't have to wash my face then?
Well, no, it's still important to keep your skin clean. And no matter how many times you wash, you're always going to have bacteria there, but that's perfectly healthy.
Never get caught out in exams. Remember, a scatter graph can show a positive correlation, a negative correlation, or no correlation whatsoever. Anyway, I'll have to get some spot cream. This is for you, Katie, not me, obviously.